All right, so y'all go ahead and do the factoring and the math knowledge question for today. Pause the video, and then once everyone is finished, you can unpause the video and I'll go over the correct answers. So for the factoring, the two numbers that multiply to give you negative 90 and add to give you a negative 1 are going to be x minus 10 times x plus 9. So that will be your answer for the factoring. For the math knowledge question, we have a quadrilateral and a triangle. What is the sum of all the angles? So this is a triangle. And the sum of those angles is going to be 180. And then this is a quadrilateral, and the sum of quadrilateral is always 360. So 180 plus 360 is going to be 540. And so C would be your correct answer. Okay, for lesson 7, we're looking at using inductive reasoning. So hopefully after this lesson, you'll understand how to use inductive reasoning to solve your problems. So looking at inductive reasoning, it's the process of reasoning that a rule or statement is true because several specific cases are true. So based on information that we've received in the past, we're going to think that something is true because of what's happened in the past. Conjecture is a statement that is believed to be true. So when we use inductive reasoning, we are going to be making a conjecture about what will happen in the future. So let's look at an example. We want to formulate a conjecture regarding the number of squares in the fourth step of this series. So it looks like we start with a square and then we add 1 to every side. And then we took a square and we added 1 to every side. So the next one would be to make a bigger square. And then to add 1 to every side. And then you would just count your squares here. So this is a 5 by 5, so that would be 25, 26, 27, 28, 29. But that may not be what you thought the pattern was. You may have thought that it would look more like this, where it's a stair step on the sides. And that's okay. It said make a conjecture. It didn't say what's for sure going to happen, because we don't know. We weren't really given enough information to be able to make a great conjecture. So this would be 25 and then plus 4, plus 4, plus 4, plus 4, which would be 37. So if you'd come up with 37, that could also work. On the test, whenever you make a conjecture, you're usually going to have to explain, and you would just explain your reasoning, that this is what you thought it would do. So just because you're making a conjecture doesn't mean you'll make the same conjecture as your neighbor. Now, it is possible that your conjecture is wrong because of you misunderstanding some of the information they gave you or misreading the question. So you have to be careful about that. But you are possibly going to have a different conjecture from your neighbor, and that's okay. So a counterexample is an example that does not support the conjecture. So if I say that all the girls have on a red shirt today, there is probably someone that is a counterexample to that statement. So if there is one person, one girl, I said girl, so if there's one girl that does not have on a red shirt, then she is a counterexample to the conjecture that I said. You only need one counterexample, although I'm sure that there are several girls in there that do not have on red shirts. But you only have to have one counterexample. So let's look here. Michelle made the conjecture. The expression 6n plus 1 and 6n minus 1 will always result in two prime numbers. Show that this conjecture is true for n equals 1, 2, and 3, but not true for n equals 4. So prime numbers are numbers that are only divisible by 1 and itself, in case you've forgotten that. So 6 times 1 plus 1 is 7, and 6 times 1 minus 1 is 5. So those are both prime. It works for n equals 1. For n equals 2, 6 times 2 plus 1 is 13, and 6 times 2 minus 1 is 11. It works for both of those, because both of those numbers are prime. For n equals 3, 6 times 3 plus 1 is 19, and 6 times 3 minus 1 is 17, which it works for both of those. But it says it's not going to be true for n equals 4. So for n equals 4, 6 times 4 plus 1 is 25, and 6 times 4 minus 1 is 23. This one is not prime. So that's how you can show that the conjecture is false. Okay, looking at part B. Maria looks at the diagram below and conjectures that the number of triangles in the figure is given by 2n plus 1. Is it true for all of the 4 sets that they show? Well, this is when n equals 1. 2 times 1 plus 1 is 3. Do we have 3 triangles here? We do, so it works for that one. 2 times 2 plus 1 is 5. Do we have 5 triangles here? We do. So that is the correct answer. Let's look at this one. 2 times 3 is 6, plus 1 is 7. Do we have 7 triangles here? Okay, so that one works. It gives the right answer. And then looking at this one. 2 times 4 is 8. Plus 1 is 9. Do we have 9 triangles here? So is this conjecture true for the 4 steps that are shown? Yes. Okay, so now we're going to look at example 3. Miguel made the conjecture the square of an even number minus 1 is divisible by 3. We want to test it for 2, 4, and 6. So the square means you square it. So 2 squared, and then it says if you subtract 1, it should be able to be divided by 3. So 2 squared is 4, minus 1 is 3, and if you divide by 3, does that give you a whole number? It does work for n equals 2. Let's try for 4. So we're going to square the number and then subtract 1 and divide by 3. So 4 squared is 16, minus 1 is 15, and then if you divide by 3, is that a whole number? Yes. So it works for 2 and for 4. Now let's test 6. The square, so 6 squared minus 1 divided by 3. 6 squared is 36, minus 1 is 35 over 3, which does not work because that does not come out as a whole number. Okay, so that's how you can test a conjecture. So it's true for the first 2, it's not true for 6. For this next one, we have a conjecture that is given by 3n minus 1 plus 1. Test it for the first 3 they give us. So if we plug in 1 here, 3 times 1 minus 1, that's 0, plus 1 is 1. And that's supposed to tell us how many triangular areas we have. Well, we only have 1 triangle here, so it works for the first one. For the next one, 3 times 2 minus 1, 2 minus 1 is 1, times 3 is 3, plus 1 is 4. So how many triangles do we have in our figure? Well, we have 1, 2, 3, 4 small ones, But then we also have one big one. So it does not work here because we actually have 5 triangles. So that's what I wrote, 5 triangles. So it does not work for this one because it said we should only get 4. Now let's test the next one. 3 minus 1 is 2, times 3 is 6, plus 1, we should have 7 triangles. So we've got 1, 2, 3, 4 itty bitty ones, and then we have 1, 2, 3, 4 bigger ones, and then we have one big one. So 4 plus 4 plus 1, that was 9 triangles. So it does not work for the second one or the third one. Okay, looking at the next example. On her walk, Janet spotted several birds, all of which were brown. She guessed that only brown birds lived near her. How could she test her conjecture? Well, she can test it just by observing the color of the birds she sees near her house. If she only continues to see brown birds, then her conjecture is probably correct. If she finally sees one that's not brown, then that would prove her conjecture false. Technically, she may not ever really be able to prove this because there could be a bird that's not brown that she doesn't ever see. Maybe it comes out at night and so she never sees it. So it would be really difficult for her to actually prove if this conjecture is true or false. But she could test it just by observing more birds around her neighborhood. So let's look at some practice problems. Y'all try these by yourself and then unpause the video and I'll go over them for you. So we want to formulate a conjecture about how the next value in the pattern would be found. So some of y'all may already know this one. This is called the Fibonacci sequence. And so what you do here is this number plus this number equals the next one. 1 plus 1 is 2. And then 1 plus 2 is 3. And then 2 plus 3 is 5. And then 3 plus the 5 is 8. 5 plus 8 is 13. 8 plus 13 is 21. 13 plus 21 is 34. 21 plus 34 is 55. 34 plus 55 would be 89. And so all you're going to do is add the previous two values to get the next number. So that's what you would do. For the next one, it says, test our conjecture that every even integer 4 through 14 can be written as the sum of two prime numbers. So we want to try 4, 6, 8, 10, 12, and 14. So it says as two prime numbers. So 4 could be 1 plus 3 or 2 plus 2, either one. So that one does work. 6, you could do 1 plus 5 or 3 plus 3. Either one of those would work. For 8, you could do 1 plus 7 or 3 plus 5. Either one of those would work. For 10, you could do 3 plus 7 or 5 plus 5. So that one works. For 12, you could do 1 plus 11 or 5 plus 7. So that one works. For 14, you could do 1 plus 13, 3 plus 11, or 7 plus 7. So it does work. You only needed one of these, but I was trying to give you all of the different options that would work. Okay, let's look at one more practice problem. So y'all think about this one and then unpause the video and I'll go over it. So it says apples, pears, lemons, and peaches all grow on trees. Therefore, all fruits grow on trees. Basically, you just need to find an example, a counterexample for this one. Do all fruits grow on trees? No. Grapes are a fruit, right? They grow on vines. So there's a counterexample. Another one. Watermelons. They grow on the ground, on vines. But you only need one, so just pick a fruit that does not grow on a tree. Another one would be strawberries. You can keep going though. Just pick a fruit. That's all you have to do. Alright, so now we're going to look at the challenge question for today. So y'all pause the video and think about this one, and then unpause it, and I'll go over it. So Isaac draws one marble and records its color and returns it to the bag. And he does it 20 times, and every time he's gotten a red marble. So he says that all the marbles in the bag are red. His friend observes the experiment, makes a conjecture that there exists a differently colored marble in the bag. One of the conjectures is true. Which one is more valid? Explain. So this is actually kind of a trick question. It tells you one is true, but we don't know which one. Either they're all red or there is at least one that is not red. Both of the conjectures are equally valid, so one is not more valid than the other. Through our inductive reasoning, it supports that Isaac is correct because every time we've only gotten red, so we kind of think that we're only going to get red. But neither one of them can be proven or disproven until we draw another marble or until we just dump out all the marbles and look at them to see if there were any others that were not red. So one of them is true, we don't know which one, but both of the conjectures are valid. So that would be your answer there. So make sure that you do your homework 1 through 30 tonight so we can go over any questions you have tomorrow.